The sun and the moon, traditionally regarded as two opposites, the god of day and the goddess of the night. When visible, the moon is the brightest object in the night sky, due to its proximity and its reflection of the sunlight. Its quickly changing figure throughout the month led humans to make use of its phases to calculate time and to regulate agricultural cycles. The moon is the Earth's only natural satellite, the natural satellite par excellence, so much so that all the planet's natural satellites are called moons. The moon is made of rocky ground and has no atmosphere. Consequently, all the asteroids that impacted against its surface created the familiar irregular appearance, made of craters and plains. The moon spins around its axis and revolves around the Earth with an elliptical orbit, with the Earth placed in one of the foci. Therefore, the moon will be closest to the Earth at the perigee, and farthest at the apogee, appearing slightly bigger when at the perigee. The lunar orbital plane is inclined of around 5 degrees with respect to the ecliptic, meaning that most of the time the Earth, the Moon, and the Sun do not lie on the same plane. The intersection of the ecliptic and the lunar orbital plane is called the line of nodes, and the corresponding points on the lunar orbit are the ascending and descending nodes. Only when the Earth, the Moon, and the Sun are aligned along this line, eclipses can happen. The Moon rotation axis is inclined of around 1 degree with respect to the vertical to the ecliptic, meaning it's almost vertical. The Moon's rotation and revolution periods have the same length. As a consequence, the Moon always shows the same face towards the Earth. The other side of the Moon has been observed thanks to satellites from space. The synchronization of the Moon rotation and revolution periods is an effect of the reciprocal gravitational pull of the Earth and the Moon. The phenomenon is called tidal locking, and it happens every time a binary system has been orbiting for a long enough time to slow down the rotation of the components. In the case of the Earth-Moon system, due to the large mass difference between the components, the spin down mainly affects the Moon. The Moon's revolution period is equal to one sidereal month of 27.3 days and one synodic month of 29.5 days, the latter being the period between two equal Earth-Moon-Sun alignments. The difference of about 1 day between the sidereal and the synodic month is due to the Earth's own revolution around the Sun. The Earth moves along its orbit with a consequent additional day to recreate the alignment. The synodic month is the length of the lunar cycle. Therefore, we can more simply define it as the period between two identical lunar phases. The defining traits of the Moon's orbital motion, as seen from the Earth, are the lunar phases. During the course of approximately a calendar month, the Moon appears in the sky partially illuminated by the sunlight, sometimes full, sometimes invisible. Sometimes it shines at night, sometimes it's visible during the day, engulfed by the sunlight and against the azure sky. The lunar cycle begins with the new moon, when the moon is found between the Earth and the Sun, and the Sun shines on the face we cannot see. Therefore, the new moon is technically not observable from the Earth, but if it were, it would be present during the daylight. In the following days, we can see the crescent moon, first just a sickle, then a bigger clove, best visible at the west around sunset times. It's the waxing crescent moon. The line that separates the darkness from the illuminated face, the terminator, appears definite due to the absence of an atmosphere. Its curved shape is a direct consequence of the moon's spherical shape. In about 1 week, we reach the first quarter. The right side of the moon is fully illuminated, and the moon completed 1/4 of its orbit around the Earth. In the following days, we observe the waxing gibbous moon. The first quarter rises around midday and sets around midnight, culminating at sunset. It is always found at 90 degrees from the Sun. After 2 weeks from the beginning of the cycle, the Earth is found between the Moon and the Sun. We have the full Moon. The visible face of the Moon is fully enlightened. The full Moon always rises when the Sun is setting at the opposite side of the sky, at 180 degrees. It culminates at midnight. The cycle is completed by the decrescent phase, the waning gibbous moon, followed by the last quarter. Again, at the last quarter, the moon is found at 90 degrees in the sky from the sun, culminating at sunrise. The waning crescent rises late at night and sets during the daylight, until the moon becomes invisible again.